This is part 2. Bonus test question about the Born-Haber cycle for the formation of crystal potassium fluoride. Which energy change corresponds to the ionization energy? So the ionization energy is the loss of an electron from a gaseous atom. And if you look through the cycles here, 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 and here, you'll notice that from gaseous potassium, you go to gaseous potassium with a positive charge. And a positive charge means that it lost an electron because it lost a -1 thing. And so step 3 is the ionization energy of potassium. Number 19, bonus test question, the electron affinity of fluorine. So the affinity is the opposite of ionization energy, and so it's the gain of an electron by a gaseous atom. And so first we have to find fluorine gaseous. We happen to find fluorine gaseous right here, and then you can see fluorine gaseous gained an electron right there because it came negative. And so step 4 is the electron affinity. Number 20, given the electronegativities, which covalent single bond is least polar? And then they give you the choices of many mixes of this. And the least polar, of course, means that it has the smallest difference in electronegativity. And so the differences would mean that you'd do subtraction on the periodic table. And of course, if you took 3.5 minus 3.5, you'd have a difference of 0. And that's the smallest difference you can find. And so letter E. Number 21, the molecule P2O has blank valence electrons. So add these up in the periodic table. Oxygen has 6 valence electrons, plus phosphorus, which has 5 valence electrons, times 2 adds up to 16, which is letter B. Number 22, the IBr4 ion has blank valence electrons. So iodine has 7 valence electrons. You can find that on the periodic table here. Group 17 has 7. Bromine has 7 times 4 because there's 4 of them in this formula, plus 1 more because it has a little negative sign right here. So 28 plus 7 plus 1 more gives you 36 valence electrons, which is E. Use these structures for the next number of questions. The structure of iodoethine, the formal charge of each carbon atom is, so here you can find the carbon atoms of iodoethine right here. And so you take the number of electrons assigned it on the periodic table, which is 4, because it's in group 14, minus the number of electrons assigned it on the Lewis dot structure, where if it's a bond, remember only 1 goes to one atom and 1 goes to the other. So 1, 2, 3, 4. 4 minus 4 is 0 for this carbon atom, and it will be the same on this carbon atom. So both carbon atoms have a formal charge of 0. Number 24, the formal charge on the nitrogen in hydrogen cyanide. So here's hydrogen cyanide, here's the nitrogen atom. The number of electrons assigned nitrogen on the periodic table is 5. 5 minus 1, 2, 3, 4, 5. Remember, only 1 from each bond, so it ends up being 0 as well, letter E. The next questions also refer to the Lewis electron dot structures, so I'm going to move it over here so we can see these. The number of unshared pairs of electrons in the structure of bromoethene is, bromoethene is right here, and it wants the unshared pairs of electrons. Remember, if it's a dash, it's a shared pair. So 1, 2, 3, 4, 5, 6 shared pairs. And then the unshared pairs would just be written as dots, and there would be 1 here, 2 here, 3 here on the bromine, so there would be a total of 3 unshared pairs. Next, the molecule of carbon dioxide contains blank polar bonds. So here we have carbon bonded to oxygen. It's a double bond, but it's still a bond. And here we have carbon bonded to oxygen. Oxygen and carbon have differences in electronegativity on the periodic table. Therefore, both of these bonds would be classified as polar. And so we'd have a total of 2 polar bonds. Number 25.6, if the triple bond in hydrogen cyanide were replaced by a single bond and unshared pairs of electrons were used to complete the octet on the carbon atom, which is the formal charge on carbon? So hydrogen cyanide would now, it says it were single bonds and it were unshared pairs of electrons here. What would be the formal charge on carbon? So in this case, the number assigned it on the periodic table is 4 minus 1, 2, 3, 4, 5, 6, and so it would have a formal charge of negative 2. Number 25, the oxidation number of nitrogen in NO3- is, so oxygen always carries an oxidation number of minus 2. There's 3 of those. It's got to add up to negative 1 because it says nitrate is negative 1. And nitrogen would have to fit into this formula, and therefore it would be positive 5. The oxidation number of oxygen atom in H2O2, this is the one weird exception for oxygen because usually it's minus 2. But in this case, H2O2 is the peroxide ion, and each one would be negative 1. The structure of the sulfur dioxide shows the formal charge on the sulfur atom is, so here we would take the number assigned to sulfur on the periodic table, sulfur's in group 6, minus 1, 2, 3, 4, 5. 6 minus 5 would be 1, and so positive 1, letter B. Next, number 28. The structure of the sulfur dioxide shown in the previous problem, the oxidation number on sulfur is, so once again, SO2, oxygen's minus 2, there's 2 of them, it's got to add up to 0 because there's no number written in the upper right hand corner. That means sulfur must be positive 4, which is D. Number 29. The central atom in which structure below violate the octet rule? More than one is possible. So the structures are quickly drawn right here on this answer key. I'll zoom in on them so then you can see them. And you can see that xenon has 2, 4, 6, 8, 10, 12 electrons around it, so it violates the octet rule. Iodine, 2, 4, 6, 8, 10, 12, it too has an expanded octet. Sulfur, 2, 4, 6, 8, 10, it has an expanded octet. Krypton, 2, 4, 6, 8, 10, it also has an expanded octet. CF4, on the other hand, would simply have 1 carbon and 4 fluorines around it, giving it only 8 electrons around it, obeying the octet rule. So the best answers for this, more than one answer possible, are A, B, C, and D. All violate the octet rule. Next, number 30, a carbon atom has blank valence electrons. Carbon, remember, has 4 valence electrons, and it almost always forms 4 total bonds. Fluorine atom has 7 valence electrons and normally forms 1 bond. Which orbital does an electron in the iodine atom experience the greatest effective nuclear charge? And so that would be in the orbital that would be closest to the nucleus, because then it would be attracted the most and therefore be the one that experiences the greatest effective nuclear charge. And so that would be letter A, the 1s orbital, because it's the closest to the protons. Number 33, in which orbital does an electron of barium experience the greatest effective nuclear charge? Here you're not given a 1 or a 2 level electron, so you have to pick the one that's closest to the nucleus, which would be the 3p, because of course the 4p, the 3d, the 5s, and the 6s all fill later, and the electrons would be further away from the nucleus. More in the next video.